Anytime you want to start.
How to solve for all rational zeros by Adam Martillo. The first thing you need to know is what is a rational zero. A rational zero is a number that makes a polynomial equal to zero. A rational zero theorem is also called the rational root theorem because it gives you the bare roots of what the polynomial sets to zero. The equation I'm going to be using today is f of x equals 3x to the fourth minus 8x to the third minus 37x squared plus 2x plus 40. Now, what you need to know is what a constant is and what a leading coefficient is. A constant is the number in a polynomial that is bare, that doesn't have a variable or an exponent. In this case, the constant is 40. Now, the next thing you need to do with this constant is find every factor of the constant. The factors of this constant, which is 40, are 1, 2, 4, 5, 8, 10, 20, and 40. Now that you have all of your factors of your constant, you need to move on to your leading coefficient. Your leading coefficient is the very first term in your polynomial, and it's only the number, not the variable or the exponent. In this case, it's 3. And all the factors of 3, which is pretty simple, is 1 and 3. Now that you have all of your factors of your constant and leading coefficients, you need to plug them into what is known as plus or minus p over q. It may sound weird, but it's very simple. P is what stands for the factor of the constant, which means all of the factors of 40 that you found are on top as p. So for example, if the factors of 40 are 1, 2, 4, 5, 8, 10, 20, and 40, you'll plug in one of those numbers, which is 1. And then on top, which is part of the division, which is 1, 2, or 4, or 5, or 8, or 10, or 20, or 40. Now only one of those numbers goes on top. And since it's p over q, you need to divide it by the leading coefficient. Q stands for the leading coefficient factor, which in our case is 3, which is 1 or 3. So for example, when you make this equation go into p plus or minus p over q, you get plus or minus 1, plus or minus 1/3, plus or minus 2, plus or minus 2/3, plus or minus 4, plus or minus 4/3, so on, so on. What's happening here is that you're taking all of the factors of 40 and dividing it by all of the factors of 3. Now that you have all of your factors, when you put it into plus or minus p over q, you're going to have to plug that number, one of those numbers. Okay. Now that you have all of your factors from plus or minus p over q, you will choose one and plug it into your original equation. The one I'm going to choose, just to make life easy, is going to be positive 1. Now since it's plus or minus 1, I could have chosen negative 1, but instead I'm just going to choose positive 1. Now, if I plug in positive 1, the equation becomes f of 1 equals 3 times 1 to the fourth minus 8 times 1 to the third minus 37 times 1 to the second plus 2 times 1 plus 40. Now you solve for all this and you get at the end f of 1 equals 0. Now since we've gotten f of 1 equals 0, that's good. You want the equation to equal 0. Luckily, the first term I picked was 1, and that was correct. But if you had chosen another number, like negative 1 or 1 over 3, and it didn't equal 0, that means you need to try again. The weird thing is that when you plug it into a function, the equation for a function is x minus whatever number. So since we used positive 1, the function is x minus 1. And this is called the remainder theorem. Next, we will plug in our function x minus 1 that we just solved for by plugging it into an equation called synthetic division. I know it looks really complicated, but it's just because I drew all over it to explain what's going on. In a second, you'll understand how easy this is. Now, since we chose our factor 1, which turned out to be right, you place your factor here, where it says 1. And that just, I'll explain in a second. Now, these numbers up top, 3, negative 8, negative 37, positive 2, and positive 40, are all the numbers from our original equation, which was f of x equals 3x to the fourth minus 8x cubed minus 37x squared plus 2 times 1, or 2x plus 40. Now, all I did there was take the first numbers, the leading coefficient of each term, and put it. So this would mean, since it's 3x to the fourth, you put 3. And then next would be, since it's minus 8x cubed, you would put minus 8. So on for the rest of the equation. Now these arrows are just explaining what's happening. For every term, you need to multiply it by the number here. So 1 times 3 equals 3. And now what you do is you take the number that you got and you place it up here. And now you know that negative 8 has to be added by 3. And so now negative 8 plus 3 equals negative 5. And now you take the negative 5 and you multiply it by 1. And now you put the negative 5 that was multiplied by 1 here. So this is just this times that put up here. Now negative 37 plus negative 5 is negative 42. Now 1 times negative 42 is negative 42. So now you add positive 2 and negative 42, which gives you negative 40. Now you multiply the 1 times the negative 40, so that equals negative 40. And now you add 40 and negative 40, which gives you 0. That's good, because that means that there is a remainder of 0. What you see here is this is the remainder. This last column, no matter where it is always, the last column is always for the remainder. So if the remainder equals 0, that means there's nothing left over and it fits perfectly, which means you've used the right number. So now what you do is, in your original polynomial, it started out with 3x to the fourth, 8x cubed, 37x squared. So as you can see, what I've done here is I've reduced the exponent by 1, which is what you have to do. So however many exponents, whatever was 2 in your first equation, you need to subtract by 1, because by doing this, you've gotten rid of an entire term. In the first equation, there was 1, 2, 3, 4, 5 terms. And now, since we've done the synthetic division, we've reduced it down to 1, 2, 3, 4 terms. Remember, that's the remainder. That doesn't count. So now, the equation we have is 3x cubed minus 5x squared minus 42x minus 40. Now, the equation we just got was 3x cubed minus 5x squared minus 42x minus 40. Now, we have to use the terms we found before, the plus or minus p over q, and do the same exact thing. Now, what you're doing is you're just taking another random term from our list of 1, negative 1 over 3, 2, 2 over 3, 4, 4 over 3, 5, 5 over 3, 8, 8 over 3, blah, 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 so on. Now, I've chosen negative 2, just because, I don't know, I think it fit. Remember, if yours didn't equal 0 at the end, it's okay. Just go through your terms that are right here and find which ones equal 0. And that's perfectly fine. I just chose negative 2 because I knew it would work. So then our equation now is g of x. I use g of x because I don't want to get confused with our original equation, which was f of x equals 3x to the fourth minus 8x cubed minus 37x squared plus 2x plus 40. I don't want to get that equation mixed up with my original one, so I just changed the variable in the beginning. Instead of f of x, I put g of x. You don't have to do that, I just think it's easier. Okay, so now our equation that we just solved using synthetic division is g of x equals 3x cubed minus 5x squared minus 42x minus 40. Now remember that I chose negative 2, so I will plug that in now. So g of negative 2 equals 3 times negative 2 cubed minus 5 times negative 2 cubed, squared, minus 42 times negative 2 minus 40. And now we solve the rest and it equals 0, which is good. That's what we wanted. So now, since remember I told you that to put these into a function, you need equation x minus blank. But since we've chosen the factor negative 2, x minus blank becomes x plus 2, because a negative and a negative equals a positive. So now it's x plus 2 is one of our functions. Now that we found another function that we used is correct, we will plug that into another synthetic division. Now it's the same exact thing as before. The term you found that made the polynomial equal to 0 goes here. We chose negative 2, so negative 2 goes here. Now, it's the same as before. Negative 2 doesn't matter actually. You don't multiply the first term, so first term just goes straight down. 3. 3 times negative 2 equals negative 6. Negative 6 plus negative 5 equals negative 11. Negative 11 times negative 2 equals 22. 22 plus negative 42 equals negative 20. Negative 20 times negative 2 equals 40. And now as you can see, remember I told you this last column is the remainder. The remainder equals 0. That means it's correct. So now our equation is 3x squared minus 11x minus 20. Now, as one of our last parts of this equation, we will factor out the equation we have. Since we've gotten it down to an x squared, x, and a regular number, we can find the factors. Now, since there's a 3 in front of x squared, we can't factor because we can't take out 3 in the equation. So what you have to do is multiply 3 and negative 20 together. 3 times negative 20 equals negative 60. Now, if we want to factor, we have to find all of the factors of negative 60. And all the factors that we needed to go through, it's not all the factors, but are 2, negative 30, negative 2, 30, 4, negative 15, negative 4, 15. And now we know that the factors of this have to multiply to negative 60 and add up to negative 11. So I know that 2 plus 30 does not equal negative 11. Negative 2 plus 30 does not equal 11. 4 and negative 15 do add up to negative 11 and multiply to negative 60. So these will be your terms to use. Now, since you've multiplied the first term and the last term, when you factor, you have to put 3x in front of both equations or both functions. This gives you 3x plus 4 and 3x minus 15. Dad. Sorry, no, I have one more page left. Can you come check if it's still in the part? Now set all the functions you've found equal to 0. Now think back. The functions that we found were x minus 1, x plus 2, 3x plus 4, and 3x minus 15. So now all we have to do is set each individual function to 0. So x minus 1 equals 0, x equals 1. X plus 2 equals 0, x equals negative 2. 3x plus 4 equals 0, x equals negative 4 over 3. 3x plus minus 15 equals 0, x equals 5. Now we have found all possible zeros to the polynomial that we started out in the beginning with. The equation we started out with was f of x equals 3x to the 4th minus 8x cubed minus 37x squared plus 2x plus 40. Now we have solved all possible zeros for that equation, which are 1, -2, -4/3, and 5. Congratulations, you've now solved how to find all rational zeros of a polynomial function.